Hello and welcome to Mastering Microsoft Excel video series. This is video number 36 where we're going to talk about the forecasting function LINEST. Without much ado, let's get into Excel and explore about this formula. Alright, so we are in the second category of the prediction methodology, which is regression based methodology. So now when we talk about regression based methodology, understand the value which you want to predict is called dependent variable. Other variables which are going to help you to predict these numbers are called independent variable. Okay. Again, let me repeat it. The value which you want to predict should be treated or should be called as a dependent variable. Now, for whichever values which you want to predict those numbers, those are called independent variable. Now, example, when my head count is 120 people, my productivity is 1 lakh unit. When my head count is 150, what is my productivity? Now, let's say if that productivity, what I'm getting is derived through a simple calculation, then obviously it is very easy for me to find it out by direct calculations, or I can use what if analysis tools like GoalSeek or Solver. Let's say I don't have any kind of arithmetic expressions or formula to derive to those numbers, the productivity numbers. Then in those cases, the regression based analysis will help you to get to those numbers. The only thing which you have to take care, these guys should be related to each other. My productivity should be related to the manpower, which is obvious because the number of manpower is definitely have an influence over my productivity. So only those kind of variables can be taken into analysis for the predictions. All right. So now when you talk about the dependent variable which you want to predict based on the independent variables, now remember that it can be one independent variables, it can be multiple independent variable also. Example, same productivity, I want to predict based on the manpower as well as the shift, the man hours as well. Okay, so man hours, manpower are two independent variable which I want to use it to predict the dependent variable, which is my productivity. All right, so let's get into Excel and let's take an example to give you more clarity about this type of predictions. Okay, so for this video, this is the Excel file I'm going to use. Now watch closely here. There are two independent variables I have and one dependent variable I have. The one which I want to predict is the cost. How much cost will I incur when my head count is 20 and my projects are 7? Here I have one dependent variable which I want to predict, which is department cost, and two independent variable which is head count and the active projects. But I do not have a calculation how these numbers were derived. This 85,000 was derived when the head count was 15 and the active projects were 3. Because I don't have any kind of calculation, but I know that these numbers are having an influence over this dependent variable. So I want to know what is the cost for the July when my head count is going to be 20 and the number of projects are going to be 7. So I want to get a new project and I want to get some new guys and I want to know what's the extra cost I'm going to incur. Okay, so now I have two independent variables and I have one dependent variable. The reason why I keep stressing on these, because that's the term people use it when it comes to LINEST or regression models. All right, so we're going to go ahead and write the LINEST formula to get it over here. So I'm going to write it in separate place so you can understand what is going to come out as a result and how do you need to use these results. Okay, so LINEST. So when I read it out, it returns a statistics that describes a linear trend matching known data points by fitting a straight line using a least square method. So too much jargons inside. So it's not going to be a kind of a single value. So that's what it's saying. It's going to give you a statistics. Okay, understand. Let's find out what's going to come out as an answer. So known y's, which is this one for us. That's the predicting value which I want to predict. Come on, known x. In this case, I have 2x, which is these two values, which are the x. Okay, this is the first time we are selecting two dependent or two x components. Okay, come on. Again, it's going to ask you whether you would like to calculate the b normally, or you want to set it to 0. I want to calculate it normally. And the fourth one is, do you want to see few more statistical inputs as an output? Well, I don't want to see that. I'm okay to get the actual output of this formula, not too much information, but I do have an explanation when you go for the choice true. Okay, so when I hit enter, watch closely. What am I getting here is these numbers, but not my actual predictions. All right, so how do I make use of these numbers, my friend? Again, so you need to get into the equation like y is equal to mx plus b. Y equal to, let me write this, y is equal to mx plus b, which is a linear. Now this case x is only 1. Now this time you have 2. So what's going to happen is your equation changes to like this: y is equal to m1 x1 plus m2 x2 plus, if there are few more independent, those will also come in, but we got only 2 independent, so we have m1 x1 m2 x2 plus b. So here x is nothing but, x1 is nothing but your head count, x2 is nothing but your active projects. Then what is m1? This 3450 is your m1, and 1850 is your m2. Then guess what's b? That's nothing but your 47,283. So you got to substitute these values in this equation to derive to this number what you are looking for. So look at the way I'm going to use this right now. Equal to this value, which is my m1 into x1 plus m2 into x2 plus my constant, the b. So when I hit enter, that is my prediction. Okay, so that's how you use the LINEST formula. So LINEST doesn't give you the actual predictions what you got in the time series forecasting, but in regression it gives you the slope and the intercept. The m is the slope and b is the intercept. Or put it this way, you get the m value and the constant value and use that inside and get it out for you. So okay, so LINEST formula does not give you a single value output like what you got in the time series forecasting formulas. It always gives you the m value and the b value, and you got to substitute in the equation and derive to those numbers. All right, so do remember that that's what is going to come as an answer. So you need to write it in a separate place. Do not write the LINEST formula where you already have a value. Then these will be overwritten, or you might get a spill error, because LINEST is again an array formula. If you do not have it, you can't use it. You might need to use a Ctrl Shift and Enter. Now remember that when we were writing formula, there were few more there was an option to go for true to get additional statistics values. So when I hit enter, this is what is going to come as an answer for you. But ideally, the value which you will be using to predict the number is the first row only. The rest of the things is all completely statistical output. Now, what are those values is what is defined over here for you, for your help. So when you download this file, my friend, watch out what each of these values are mean. So m1, m2, we got these values, and here you can see this 1629 is nothing but the standard error for the slope 1, and the 1239 is for the standard error of slope 2. So I'm not going to get into the statistical part, but that's what it gets. So what I want you guys to keep in mind is when you write LINEST formula, don't expect one output. It's going to be 3 outputs, and you got 3 or more, depends on the number of x in your equation. Yeah, and that's how you should use the LINEST formula. I hope you got the understanding about the LINEST formula, and with which we also saw how do you do a regression based prediction. But in the next video, I'm going to come up with something really interesting Don't miss it. Watch the video number 37. All right. Until then, take care of yourself. Signing off. Hariharan.